We've covered determining the margin of error and confidence intervals for means from both large and small samples, as well as determining a margin of error and a confidence interval for a proportion. So we're going to walk through an example of each. In this first example, a random sample of 35 first-year college students were asked how much they spent on entertainment during the year. The mean was $825 with a standard deviation of 240. We're going to construct a 90% confidence interval for the average spent on entertainment during the first year in college. Well, the first thing to note here is that we have a sample size greater than 30. We have 35, and we're talking about means. We have the word here, the mean was $825. We're looking for averages, so we're talking about one of these two formulas. This formula here is what we worked on this week, which is for proportions or percentages. This is for a margin of error for a large sample, and this is for a margin of error for a small sample. And that delineation for large versus small is 30. So we have a sample of 35, so we're going to be using the Z critical value for a particular confidence level. And that is this table right here. So we're looking for a 90% confidence interval. So we're going to go to 0.90 or 90%, and 1.64 is our critical value. 1.645, excuse me. And we're going to multiply that by the standard deviation, which is 240, and divide all that by the square root of the sample size, n, and in this example, that happens to be 35. So I'm just going to use Excel to do my math for me. The first thing I want to do is 1.645 times 240, and I forgot to put the equal sign in the front. I'm just typing that in, as you can see right here, and that gives me 394.8, and I'm going to divide all that by the square root of 35, and I can do that in Excel with equal square root of 35, and that's 5.916. And I'll just do that math out. I'm just going to take the 394.8 and I'm going to divide that by the 5.916. Excuse me, and when I get 66.73, and that is my margin of error. And then, as you recall, to create your confidence interval, you simply subtract that from the mean and add that to the mean. The mean in this example is 825. So I'm going to go equal 825, and I'm going to subtract 66.73. That gives me 75.27. And I'm going to do equal 825, and I'm going to add 66.73. I'm just using Excel for my calculator. So I got 758.27, and I have 891.73 as my confidence interval. So what that means is I can say with 90% confidence that first-year college students spend between $758.27 and $891.73 on entertainment in their first year. We could also use this formula, confidence.norm, to determine our margin of error. So we did out all the math here and use a formula, or using Excel, I can use confidence.norm. I just start typing it in and then double click on it. Alpha is what it wants. So instead of 90%, we do 1 minus 90%, which is 0.1. Our standard deviation is 240. Our sample size is 35, and that gives me my 66.727 or my 66.73. So this is another way using confidence.norm to get your margin of error versus doing it out manually. Okay, let's go to the next one. The Paralyzed Veterans of America is a philanthropic organization that relies on contributions. They send free mailing labels and greeting cards to potential donors on their list and ask for voluntary contributions. To test a new campaign, they recently sent letters to a random sample of 100,000 potential donors and received 4,781 donations. Give a 95% confidence interval for the true proportion. We're looking for a proportion of those from their entire mailing list who may donate. So success is the number that donated out of the total number that was sent out. We are using what we learned this week, which is a critical value z at a particular confidence level times the square root of the proportion or the probability of success times the probability of failure divided by the sample size, taking the square root of all of that. So we need to determine what P and Q are, and P is simply, out of our sample, the number that did return donations, which is 4781, and we're going to divide that by our sample size, which was 100,000. And Q is just 1 minus the probability of success, because the probability of success plus the probability of failure is equal 1. So I'm just going to do the sum of these two numbers, and it should equal 1, which it will. Yep. Because there are only two things that can happen. Either you do return a donation or you don't return a donation. So we have P as 0.04781 and Q is 0.95219. So we're going to multiply those two together and divide them by the sample size and then take the square root. So I'm going to take this number, I'm going to multiply it by this number, and I'm going to divide the whole thing by the sample size, which is 100,000. That gives me this here, and I'm going to take the square root of that. Don't let that e with the minus 0.7, that just means that our decimal place would move 7 places to the left if we wanted to write it out. So we're going to take the square root of that number, which is 0.000674716. I'm just doing this portion of the equation, and now I'm going to multiply that number by our z, which is for 95%. It is 1.96. I'm just looking right here. Multiply, excuse me. I'm going to take that number and multiply it times 1.96, and we've got 0.001322, and that is our margin of error for this example. We've got E equals 0.00132. And now, to create our confidence interval when we're talking about proportions, is we subtract that margin of error and add that margin of error to the probability of success, which is the 0.04781. So we got that number right here. I'm going to take that number, 0.04781, and I'm going to subtract my 0.00132. And I'm going to take this number here, which is my probability of success, and I'm going to add my 0.00132, which means my confidence interval is 0.04649, 0.04913. So that means with 95% confidence, I can say that when I mail out my, these greeting cards and labels, that between 4.6% and 4.9% of the people that receive these greeting cards and labels will return a donation. Okay, lastly, your uncle keeps a record of gas mileage every time he fills up. The mean miles per gallon and standard deviation determined after 5 visits to the gas station was 20.1 miles per gallon and a standard deviation of 0.96. So this mean and standard deviation were determined from the sample of 5 visits. Let's assume that miles per gallon is normally distributed. We want to estimate the true miles per gallon for the car with 90% confidence. So let's go to the flow chart to determine what we can use. Is n greater than or equal to 30? Well, n is our sample size. Our sample size is 5. We grabbed information from 5 visits to the gas station, so no, it is not greater than or equal to 30. Is the population normally or approximately normally distributed? We're told in the question that miles per gallons are normally distributed, so the answer is yes. Is a population standard deviation known? No, it is not. We have a sample standard deviation, so the answer is no. So we fall down here, and we're going to use the t-distribution. So I have that formula right here. We need to find t at a particular confidence level, and we have a 90% confidence level. And if you remember to use this table, we have 90% confidence level, and we use degrees of freedom when we're using this t-distribution. And degrees of freedom is just your sample size minus 1. So our sample size is 5, minus 1 is 4, so we have 2.132 is the t-value that we're going to use. I want to show you that this formula here in Excel, t.inv.2t, is what you can use instead of the table if you're so inclined. We put in our probability, or alpha, which is 1 minus a probability, so 0.1, and then the degrees of freedom was 4, and that returns that 2.132. So you can use this in Excel, or we can use the table, and we get our critical value of 2.132, and we multiply that by the standard deviation, which is 0.96, and we divide that by the square root of our sample size, which is 5, so the square root of 5. So let's do 2.132. Excuse me, I didn't mean to do that there. Equals 2.132 times 0.96, and what do I get? I get 2.046, 2.04, we'll just go 7, round it to 3 decimal places, and we're going to divide all of that by the square root of 5, not 50, equal the square root. That's another formula in Excel of 5 is 2.24, and now I know that I need to divide 2.047 by that. So 2.24, and I'll do that right here. I'll say equal 2.047 divided by 2.24, and that gives me 0.914. So my margin of error is 0.914. I am going to use or show you as well confidence.t is another formula in Excel, which will give you your margin of error when you're using the t-distribution. It's looking for alpha, again that's 0.1, my standard deviation, which is 0.96, and the size, which is 5. If it asks for degrees of freedom, you subtract 1 from the sample size. If it's just asking for size, it truly is the sample size. And as you can see here, we get 0.915. I did it manually. I got 0.914, so probably my rounding messed that up a little bit. So that is our margin of error. Again, we would subtract that from the mean and add that to the mean of 20.1 to create our confidence interval.